In this tutorial, we'll be looking at the detonator from Adventure 5. In Adventure 5, we introduce hardware and electronics to our projects, and the detonator uses a physical button which, when you press it, it counts down on a 7-segment display 5, 4, 3, 2, 1 before creating a huge explosion within Minecraft. Before we look at the hardware and the program, let's see the detonator in action. When I press the button, a block of TNT appears and the counter counts down before bang. Let's say that one more time. When I press the detonator, a block of TNT appears, the segment display counts down before bang. So, let's have a look at the hardware and the electronics. There are 4 main components in the hardware: the breadboard, the button, the 7-segment LED display, and in this case, a Pro Micro Arduino. If you're using a Raspberry Pi, this would be your Pi Cobbler or similar connector. It's really important when connecting your button and 7-segment display that you connect it to the right pins on your Arduino or Pi Cobbler. We're also using resistors for both the button and the 7-segment display, but for different reasons. The resistor for the button is to provide a pull up, or to actually stop random signals being created, which either your Arduino or your Raspberry Pi would pick up as button presses. We're using resistors on the 7-segment display to limit the amount of electrical current that gets passed to the LEDs themselves to stop it burning out. Now let's have a look at our program and see how it interacts with both our electronics hardware and Minecraft. So the first thing we do is import both the Minecraft and the block modules. We're going to need those to interact with Minecraft. We're also going to be using time to introduce delays. The other module we'll be using is neio.seg7. This allows us to control the 7-segment display, and we're going to call that module display. This part of the code is where we need to set it up specifically for the hardware that you have. If you have a Raspberry Pi, you'll be importing rpio.gpio and call it GPIO. You'll also be using the following pin numbers for the LEDs on the 7-segment display and pin number 4 for the button. If you're using a PC and Mac and an Arduino, we'll import neio.gpio and call it GPIO, and again set up our pin numbers for the 7-segment display and the button. Please note that they are different between the Raspberry Pi and the Arduino, so it's important that you get them right. The next thing we do is set the mode for the GPIO before setting up the button pin as input, meaning that we expect to read data from it rather than writing to it. We're also going to set a constant called on for our type of 7-segment display. Most 7-segment displays are a common anode, and we'll set it to false. If you have a common cathode display, you would set it to true. Next thing we do is then set up the display module, passing it the GPIO that we're going to be using, the pins that we want to use, and whether we're going to be using on as false or true. The next thing to do is to connect to Minecraft. We're going to create a function called bomb, which when you pass it an X, Y and a Z, will place a TNT next to that set of coordinates, and then start the countdown. And it does this using a for loop. So it counts down 6 numbers from 0 to 5, and then using the 7 segment display which we set up earlier, it writes 5, 4, 3, 2, 1, 0 by taking 5 and minusing the number in the current for loop. Each time it writes a number to the 7 segment display, it waits for 1 second until we reach 0 and the for loop ends, where we post to the chat bang for our explosion and use set blocks to clear a huge area. And this function will run every time the button is pressed. So the main loop of the program uses a try. It uses a try and finally. The reason try and finally here is the code underneath the try will run until an error occurs or you press Ctrl C, at which point the code under finally will run. And it's important that we do that because when our program finishes, whether it finishes because we ask it to or whether it finishes because of an error, we want to call GPIO.cleanup, which puts the hardware back into a safe state. But while the program's running, it will run forever and it will sleep for 0.1 of a second. And each time it runs through this loop, it will check to see, is the input on the button GPIO pin false? If it is false, it means the button has been pressed. When the button has been pressed, we ask Minecraft for the position of the player and pass that position to the function bomb, which we defined earlier, which will create a block of TNT, count down and finally create the explosion. Once bomb finishes, it will come back to the top and you can then create your second bomb.